For less than a decade, we've known that our solar system is not an island. We now know that objects from other stars pass through our cosmic neighborhood. We've seen two before. One was a mystery. The other was reassuringly familiar. Now, a third visitor has arrived. And with every new piece of data, the picture gets stranger. This object, 3I/Atlas, is moving with a speed that is difficult to explain. Its trajectory is unusual, and early observations have created a scientific paradox so profound it forces us to question our place in the galaxy. With every answer, 3I/Atlas is becoming less ordinary. And that raises a question some scientists hesitate to ask: what if this isn't just a comet? For centuries, no object from beyond the sun's gravity had ever been confirmed. We assumed that if something did pass through, it would be rare. That assumption didn't survive the last decade. In 2017, we detected Oumuamua, the first confirmed interstellar object. Small, dark, with no visible tail, it accelerated in a way we still can't fully explain. It remains a complete enigma. 2 years later, 2I/Borisov arrived. Borisov was a relief. It looked and acted exactly like a comet, proving that normal comets are in fact ejected from other star systems. Then came silence until July 1, 2025, when 3I/Atlas entered the picture. It was discovered by the Atlas survey in Chile, a faint smudge of light moving against the stars. But as its path was calculated, astronomers realized it was on a hyperbolic trajectory, the unmistakable signature of an object not bound by our sun's gravity. It came from interstellar space, and it will never return. This immediately placed it in an exclusive club. But this one was different. This one was unbelievably fast. The first clue that set 3I/Atlas apart is its velocity. To escape a star system and travel the galaxy, an object needs speed. This is measured by its hyperbolic excess velocity, the speed it retains far from any star's gravity. For comparison, Oumuamua's was about 26 kilometers per second and Borisov's was around 32 kilometers per second. 3I/Atlas has a hyperbolic excess velocity of about 58 kilometers per second. It is, by a significant margin, the fastest interstellar object we have ever seen. This incredible speed is a critical piece of the puzzle. It suggests the object didn't just drift out of its home system. It was likely ejected with immense force and has been wandering the Milky Way for a very long time, perhaps for millions or even billions of years, getting gravitational kicks from stars along the way. Some astronomers have speculated that it could be a relic from the early galaxy, anywhere from 3 to 11 billion years old. Its trajectory offers another clue. It's arriving from the direction of the constellation Sagittarius, near the dense, chaotic center of our galaxy. While tracing it to a specific star is impossible, some astronomers have proposed a tantalizing, though speculative, idea that it may have originated in the Milky Way's thick disk, a region of ancient stars. If true, it could be a chemical time capsule from a different era of the galaxy's history. But to read that message, we first have to understand what it is. From the moment of discovery, the question was simple: comet or asteroid? An asteroid is rock. A comet is rock and ice, which turns to gas near the sun, creating a fuzzy coma. Pre-discovery images, including some from the Test Space Telescope, showed that it was already active when it was far from the sun, suggesting that it was a comet driven by volatile ices. But a team of researchers asked a crucial what-if question. What if it was just an inert rocky body? For it to be as bright as it appeared without a reflective coma, it would have to be enormous. And that created a paradox. Interstellar objects should be rare. If 3I/Atlas was a truly massive inactive object, the models say we shouldn't have seen it. For us to spot one, the galaxy would have to be choked with these giant interstellar boulders, a number so impossibly high it would violate our understanding of how solar systems form and eject material. The odds were astronomically low. Yet there it was. This presented a problem. Either our models of the galaxy are fundamentally wrong, or our assumption was wrong. The most logical conclusion: it must be an active comet. Its brightness isn't from a giant solid body, but from a vast cloud of gas and dust powered by a much smaller nucleus hidden inside. A theory requires evidence. To get it, astronomers turned to the most powerful instrument they have, the Hubble Space Telescope. In late July 2025, Hubble stared at the visitor, and the images it sent back were the smoking gun. The images clearly showed a fuzzy coma of dust and a distinct plume of material forming a tail. This was definitive proof of comet activity. But Hubble did more. By measuring the brightness of the coma, astronomers could calculate an upper limit for the size of the nucleus hidden inside. The data showed the core could be no larger than about 6.6 kilometers, 3.5 miles, across, and could be as small as just a few hundred meters, a small, active nucleus. The observation beautifully resolved the paradox. 3I/Atlas wasn't an impossibly large boulder. It was a relatively small snowball putting on a big, bright show. Case closed. Not so fast. In science, an answer to one question opens a dozen more. We know what it is. We have no idea what it's made of. The object is currently on its way to its closest approach with the Sun, a point called perihelion, which it will reach around October 29, 2025. It poses absolutely no threat to Earth, passing no closer than about 270 million kilometers, 170 million miles. But this close pass is our golden opportunity. This is about performing an autopsy on a piece of another solar system. To do this, astronomers are using spectroscopy, breaking the comet's light into a chemical barcode to read what molecules are present in its coma. Planned observations with Hubble will search for key elements, but the real heavy hitter will be the James Webb Space Telescope. JWST is scheduled to observe Atlas with its incredibly sensitive near-infrared spectrometer. JWST will hunt for water, carbon monoxide, carbon dioxide, and methane. The ratios of these ices are the key. They can tell us about the temperature and conditions in the protoplanetary disk where this comet formed light years away and billions of years ago. Is it like the comets in our system, or something fundamentally different? The discovery that 3I/Atlas is an active, if unusual, comet forces us to look back at our first visitor, Oumuamua. We now have 3 data points. 2 of them, Borisov and Atlas, are comets. And then there's Oumuamua, the quiet one, the weird one. It had no visible dust cloud like Atlas. It was small, dark, and seemingly inert. Yet, it accelerated away from the Sun faster than gravity alone could explain. This mystery is what led Harvard astrophysicist Avi Loeb to his controversial hypothesis that Oumuamua's acceleration could be explained if it were an artificial solar sail. Since then, other natural explanations have been proposed. One is that it was outgassing hydrogen or nitrogen ice, which would be invisible to our telescopes but could provide the gentle push. Another is that it was a cosmic dust bunny, a fractal aggregate of dust light enough to be moved by sunlight. The debate continues. The fact that Atlas is so clearly a comet makes Oumuamua stand out even more. It reinforces that our first visitor was either a very rare type of natural object or something else entirely. Atlas tells us what might be common. Oumuamua reminds us that the universe is big enough for things that are anything but. What have we learned from this third visitor? We know 3I/Atlas is an ancient traveler, an active comet on a journey from a star system we will never identify. We know it is moving at over 200,000 kilometers per hour, making it the fastest object of its kind we have ever witnessed. But the real story is just beginning. The data from Hubble and JWST will give us our most detailed look ever into the chemistry of another solar system. Each molecule it releases is a word in a message that has traveled through the dark for eons. The arrival of these visitors has changed our perspective. For all of history, our solar system was an island. Now we know there's a highway running through it. We are no longer isolated, but a port of call. And as 3I/Atlas begins its long journey back into the darkness, it leaves us with a thrilling, unsettling certainty that we are not alone.